Okay, so don't forget to turn off the microphone. Okay, today we're going to discuss complex numbers. This is Mr. Precella with his college algebra class. And the last time we had worked with square roots. Oh, let me find those. We looked at some perfect squares and got a special rule, square root of a times the square root of a. Square root times itself is whatever's under the square root. And we're going to use that today, that rule. But here's a common mistake that students make when working with square roots. I'm going to put a red X, meaning this is wrong. Suppose I had this. The square root of negative 25. Oh, wow. Can you not read it because of my big red X? Oh, it's a square root of negative 25. A lot of times students will say that's negative 5. Now that should have been where I put the big red X. Because why is that not correct?
Because negative times a negative is a positive.
Yeah, negative times a negative is a positive. So square root of negative 25 is not negative 5. Well, we also know it's not positive 5. So how the heck do we define the square root of a negative number? Well, here's what we're going to do. We're going to define the square root of a negative number to be an imaginary number. And we're going to denote imaginary numbers with the lowercase letter I. So let me go back to that square root of negative 25. Square root of negative 25, here's how we'll simplify that. Whenever we see a negative under a square root, we're going to think of that as an imaginary number and use a lowercase I to denote it. Then you just simplify the rest. The square root of 25, y'all know the square root of 25, what's that? 5, just stick an I on it. If you're following the colors, I'm writing my I in green. I guess it's hard to tell that's green because of that green negative under a square root. So in previous algebra classes, you heard teachers talk about real numbers. You've heard that phrase before probably, without them ever really defining what the heck is a real number. Real numbers, real numbers. Now you know what a real number is. A real number is any number that is not, starts with an I, imaginary. Okay? So we have real numbers, we have imaginary numbers. Let's look at, notice I can't click on any of the homework problems until I click on the videos. This is my video that I made at home during the pandemic. Oh, my poor leukemia cat, he passed away. He was here from Delmar, and so you see, you watch the video, it's me going through, working the same type of stuff, the same 15 problems I'm going to work today, okay? But you still got to check on it, even though you're hearing me say it again today. Now, Elaine Martin-Gay is working them. This is a Pearson-made video. And it has all the bells and whistles of transcripts and so forth, which mine don't. Now we're ready to do problem number 1. Okay, problem 1. I wonder if y'all could do this one without any writing. Oh, yeah, okay. Let me write it down. A lot of times students say, wait, do I have to do all that writing for problems that I can do in my head? And I always answer the same way. No, your goal is different from mine. My goal is to show my thought process, and your goal is to get the right answer. Say it again, what's the answer going to be here? 7I. What, if you're following the ink, which the colors, which color? Okay, we have a red 7, a green I. The square root of a negative number is an imaginary number. So I'll type in 7i. Notice sometimes they'll put the I down here as a hot button. I'll just use a lowercase I. Oops. Oh, wait. I think my brother disconnected the keyboard. It's a USB. There. Okay. Again, how to make a good second impression. Don't have the keyboard connected. What about number 2? Now, last time we worked with simplifying square roots, and remember we had the perfect square. Oh, the perfect squares. And if you had numbers that weren't, oh wait, right there, square root of 54. This was from my Monday, Wednesday class. So we may not have done that exact same number, but you remember how you simplify square roots that aren't perfect squares? Let's see. Problem 2. The square root of negative 54. Now, because of that green negative under the square root, I'm just going to go and write an I right off, just so I don't forget that. We have an I. It's an imaginary number because it's the square root of a negative. Now, what's the biggest perfect square that divides evenly into 54? 9? You all agree with 9? 9 times 6 gives us 54. So I'm going to write this as a blue square root of 9 times a red square root of 6 equals, in place of the blue 9, I'm going to put a 3. Theoretically, it doesn't matter where you put the I, but what we're going to do is always put the I in front of the square root symbol. Okay? If there's a square root in your answer, you'll put the I in front of it. So write it as 3i square root of 6. That's the standard form for writing it like that. If you have a square root symbol in your answer, put the I right in front of it. Okay. 3i square root of 6. Check our answer. Now, in previous, in previous algebra classes, one of the first things you learn is something called combining like terms. I remember this stuff about combining like terms. If you had 3x plus 5x, you would call that, how would you combine those? You would say it was 8x. But what if you had something like this? 3 plus 5x. Could I combine the 3 and the 5 then? No.
So it will be 5x plus 3.
Yeah, you could write it as 5x plus 3. But for our purposes, let's imagine that we're working with imaginary numbers and real numbers. A complex number is in the form A plus BI. A plus BI, that's a complex number. So imagine if there was the x here, instead of the x, an I. An example of complex numbers, 3 plus 5i. If you have a real number and an imaginary number, can you add those together?
No.
No. They're not like terms. Treat the I as if it were just a variable x. Here you can't add the 3 and the 5. So what is a complex number? That's the name of this assignment, complex numbers. Well, a complex number is a real number together with an imaginary number. On problem number 3, don't panic when you see it. I think it's going to look kind of messy. I'll tell y'all when to start panicking. Negative 2 plus, let me write it down. It's number 3. And that was a straight-faced joke, but I'll tell you when to start panicking. Hopefully you won't start panicking. Mm-hmm. 8. Negative 2 plus the square root of negative 8 all over 2. It says write this answer in standard form, and what do they mean by that? Well, down here they talk about writing it as A plus BI. This is going to be your final answer is going to be one of those complex numbers. You're going to wind up with a real number and an imaginary number which you can't add together like that. But to get started, let's simplify that square root. Let's simplify this square root of negative 8. Am I going to write a green I? Yeah. Now, 8 isn't one of those perfect squares, is it? But how would I simplify square root of 8?
Square root of 4 times square root of 2.
Did y'all hear that? You would think of it as 4 times 2. 4. And then how would I simplify that? Well, I'd write the blue 2, then the green I, and the red square root of 2. So 2, the 2 is blue because that's what we're getting from the blue square root of 4. We put the I in front of the square root symbol, okay? And then the red square root of 2. So let me rewrite all of this. Negative 2 plus 2I square root of 2 all over 2. And now, to simplify this fraction, be careful. If there's just, when you have a fraction in algebra, if there's just one number in the bottom, separate it and leave it like that and simplify it from there. What do I mean by separate? Well, negative 2 over 2. How would that reduce?
Negative 1.
To negative 1?
Why don't you write it out since it's a
Okay. I'm going to write it out. Negative 2 over 2. That's what these little bars mean here. Separate it. And then 2I square root of 2 all over 2.
Oh, this reduces nicely.
I don't normally show this step here. I'm just showing it this time to show the thought process. Usually I just make the little marks here. The negative 2 over 2 is a negative 1. Then there's black plus. What cancels here?
Not the imaginary.
The red, the 2 from the imaginary, and that 2. It's not this 2 here. The 2 under the square root doesn't cancel. So,
and I mentioned that, I think, in the last problem of homework number 1. You can't cancel something under a square root with something that's not under a square root.
As if you expect them to remember everything you mentioned. So, any questions on that? Negative 1 plus I square root of 2.
Pardon me?
Oh, yes, there's going to be...
There's several here.
There's 3 of them. Boom, boom, boom. The next one is a better example. I think it shows the pattern better.
I'll do the next one.
Oh, okay.
Wrong playlist. It had been uploaded, but...
Put on the wrong...
There was we have a different algebraic playlist. but the lecture from yesterday was on our channel, but
Put on the wrong
just
page.
clicked Math 1314, not the current Math 1314 playlist. Let me write down the problem.
8 minus the square root of negative 72 all over 2.
Okay, I got it.
And start off by simplifying that square root.
Anytime you see the square root of a negative, the first thing you should do is rewrite it using an I. So I know that's going to have an I in it. Okay, so that's an I. I like this one better. I'll put that I there. I'm just working with the square root of negative 72. Now wait a minute, is 72 a perfect square? No. What's the biggest perfect square that divides evenly into 72? I know 9 goes in evenly, but I think that's not the biggest.
36.
36, y'all agree with 36? I agree also. So we're thinking of that 72. That's the square root of 36 times the square root of 2. And, okay, that square root of 36, we're going to write that as a 6. We have the I. And what else do we have stuck on there? The square root of 2. I agree. Did I dim those lights? Y'all think it's too bright in here? It seems sort of bright, doesn't it? Tony, you want to dim the lights in both of the rooms just a little bit. So now we're rewriting. We have the 8 minus, we have that 2 there, that square root of negative 72. Don't make it too dark, it'll put everyone to sleep.
No, you're doing a good job of that.
Okay. I walked into that one, didn't I? Okay.
It sounded like you were about to just start drawing.
Okay, did y'all follow what I just did? I replaced the square root of negative 72 with 6i square root of 2. And now, if you have a plus or minus on top, something plus something or something minus something on top of a fraction, and just a number on the bottom, that's when you want to split up. So you have a complex number on top and just a plain old integer on the bottom. So you split it up, and I'm gonna show the step. 8 over 2 minus 6i square root of 2 over 2. Any questions on my logic there? I'm splitting up over that minus sign. Both of them have 2's. And now this one still works pretty nicely. Doesn't work out as nicely as the last one, but it's still a pretty nice answer. 8 divided by 2 gives me 4 minus, what can I cancel here?
2 goes into 6.
6 3 times, so we have 3i, and what else do we have? The square root of 2. Oh, I'm going to try to stop making that little hook there that Tony says looks like an exponent of 1. But after doing it for pretty much for the vast majority of my life, I think it'll be hard for me to break that habit. That green is hard to see, isn't
Well,
it?
that's not a good green.
I'm going to get
one of the better greens.
I don't know.
Don't throw it away.
I'm not going to throw it away because it's still right. I just don't want to. Okay, so let's type that in.
It's 4 minus 3i square root of 2. Somehow, yesterday I was thinking this one would have been a little messier with bigger numbers, but it's just randomly.
Now, the first 2 that we've done here, number 3 and 4, notice the fractions completely cancel out. That's not required. You may be stuck with fractions in your final answer.
Right
okay?
here, On number 5, if you look at this, 8 and 24, you're going to wind up with what number in the bottom when you separate it? 8 goes into 24, 3 times. Yeah, so this one's going to wind up with a fraction in the answer. You want to go ahead and do it?
Yes, okay. So this is number 5. Let me write the problem down.
-8 plus the square root of -20 all over 24.
You tell me, what am I going to do first? Let's switch over.
Oh.
Okay, you tell me, what am I going to do first?
Take care of the square root.
Okay, that square root of -20. I think I'll do it right up here on top, right above it. Since it's negative, I'm going to stick on an I. Is 20 a perfect square?
No.
What's the largest perfect square that divides evenly into 20?
Square root of 4.
Yeah, we'd think of it as the square root of 4. Here it is, the square root of 4 times the square root of 2.
No, I'm going to question your
Oh,
math.
it's 5. Oh, we have 5. What am I? I was looking at that 8 right there. I agree. And then the square root of 4, what am I going to replace that with?
2.
So that's going to be, we have a red 2 that came from that square root of 4. I'm assuming that my brother mentioned that multiplication is commutative, and so it's standard practice, if there's a coefficient on that I, we put it in front. We don't write I2, we write 2 and then the I, and we're left with what?
Square root of 5.
I agree.
What I say is you write the I in front of the square root, if there's an I. I mean, if there's a square root.
So we have a -8 plus that 2i square roots of 5 all over 24.
See, you did it.
I put the little thing, didn't I? And then what do? When I have a complex number on top and an integer on the bottom, you split it up, so you have -8 over 24 plus 2i square roots of 5 over 24. Now be careful, -8 over 24 doesn't reduce to -3. What does it reduce to?
-1 over 2.
That's right. There's a common factor of 8 here. 8 divided by 8 is 1. 24 divided by 8 is 3. So that leaves us with a -1/3 plus, what can we cancel here? Okay, 2 will go into 24 12 times. So we have the rather interesting looking fraction I square roots of 5 all over 12.
Ooh, it's going to be messy to type in.
First of all, any questions?
I think this is the messiest of the 3 of those. 3 like this, where you're reducing the fraction.
First of all, reduce the...
It's like a larger number.
Pardon me?
It's like a larger number.
What do you mean a larger?
100 a factor.
Instead of the 20,
Like 512.
oh,
Well,
well,
5/12's a perfect square, isn't it? And so it would work out without a square root in that case. You'd still want to split up.
5 over 12.
No, 512 is not a perfect square.
oh, it isn't? Okay, then you go through, okay. Thinking of those perfect squares, 512, let's start with, okay, does
Start with
144
144.
divide into it? Does 121.
Just go through.
Oh,
until
so do you are you looking at yours?
Yes.
Oh,
Oh.
okay. 512.
64 goes into
Oh, okay, then. You would say six. Oh, wait.
Well, I think
no, there's something bigger than that. Because 8,
64 times 8 is 256. It'd be 256 times 2. You just have to play around with it. You're going to have to go bigger than that list that we have right here.
oh, we.
Mm-hmm.
Oh, yeah. What's the square root of 256?
16.
Mm-hmm. Yeah, and so our list ends at 12 times 12. I think the last time we went up in this class, we went to 13 times 13. I'm just looking at the Monday, Wednesday, because it's right there on page 1. But if we continued, after 13 times 13, 14 times 14 is 196. 15 times 15, oops, 15 times 15, 225. 16 times 16, oh wow, 256.
That's why you need a calculator. This is what I refer to as number crunching. You're trying to find the biggest perfect square that divides evenly into the given number.
Do any of y'all, there's some Casio calculators, and maybe TI has some smaller ones too, but if you punch in square root, if you type 512, it would give you this real simplified form the way we do it, not the decimal number. Does anyone have a calculator that'll do that? It's generally smaller ones, not graphing calculators. And, maybe look into it and see. But let me go ahead and punch in that number, or this answer here.
Mm-hmm.
Okay, so it'd be negative 1, oops.
Mm.
Oh, that's not.
Well, you can do.
I'm going to do a fraction.
Oh.
Negative 1 over 3. Then right arrow. You don't want to put the plus right here. See, the plus shouldn't be in the bottom. This is sort of messy, isn't it? You go right arrow, then the plus, and then you hit the fraction key again. Okay? The I. Now here there's not an I listed. I'm once a student emailing me asking me how does she enter I. Just type it. Just type it. Just use the keyboard. I.
hit more, and it's all.
I know.
Well, what's the point of doing that? Really, you shouldn't ever have to hit more. If you have to hit more, then it's something that you can just do through the keyboard.
But they don't know that.
Mm-hmm.
So I square root of 5 over, what was it, 12?
12. Mm-hmm. Let's see.
I think yesterday when we were doing these in the Monday, Wednesday class, the numbers that were showing up were bigger than they are today. Okay, so if you look at the video of yesterday, you're going to see bigger numbers.
Any questions there?
Mm-hmm. It's so weird at times I want to turn off this calculator because I think I'm going to run the battery down. That's crazy. It's not. I keep wanting to reach over there and turn it off. But now, we're leaving those behind and going to a slightly easier problem. I've mentioned this combining like terms already. What we're about to start doing is adding, subtracting, multiplying, and dividing complex numbers. I will tell you there's not a lot of elementary applications of complex numbers. Magnetic field theory, future physicists, future electrical engineers, you'll see a lot of nice applications of complex numbers. We're not going to do that much with them. Okay? And the applications are way beyond the scope of this course. To add complex numbers, we're just going to combine like terms. We're adding and subtracting complex numbers. And Tim, you didn't write down the problem. Oh, you're going to write out combine like terms? What did you
I
write?
was going to write combining like terms.
When you're adding complex numbers, you add the real number together and then the imaginary numbers. So the parentheses around these are indicating here's one complex number, then a plus, and another complex number. So pretend these i's are just variables. You see parentheses. You know what you're doing when you have a sum or difference enclosed in parentheses. You look and see, is there something? I don't think your microphone's on. Oh, my battery's dead. Oh, my battery's dead. So you take over. These things in your office. Okay, in order to combine like terms, y'all remember distributing? If there's a number in front of the parentheses, you distribute. Well, here there's nothing to distribute, so I'm just going to rewrite the whole problem without... Huh? Oh my gosh. Okay, I'm going to rewrite the problem without the parentheses. This black plus right here is that one. And that step is one of those steps that really isn't essential that you show. You're just going to add the real numbers together and then the imaginary numbers. What can I combine with the negative 2? Okay, so negative 2 plus 9 is a 7. Now let's add the imaginary numbers together. The 4i plus 2i, what are we going to write there? 6i? Now don't get carried away and then say 13i. You can't add the 7 and the 6. To add complex numbers, you're just combining like terms. Add the real numbers together and add the imaginary numbers together. So I type in 7 plus 6i. Oops. And I'll say chuck it. Now, do you remember? Well, I'll just show you the next one. What do you do if there's a minus sign in front of the parentheses? I'm not just going to drop the parentheses. I have to do something else when there's a minus sign.
Change the sign of the number that's behind it.
Yes, that's called distributing the minus. So, to add complex numbers, you just add them together. Add the like terms. With subtracting complex numbers, you've got to distribute the minus and then combine like terms. Let me write this problem down. Number 7. 2 minus 6i. I think I'll put the subtraction symbol in red. Minus 3 plus 2i. And then another minus negative 2 plus I. Well, this first set of parentheses we don't really need. I'm just going to go ahead and drop those. There's nothing in front of it to distribute. Oh, okay, there. Let me repeat that. This first set of parentheses, we don't really need. I'm just going to drop them. Okay, there's nothing to distribute there. So we have 2 minus 6i. I'll call that first set of parentheses unnecessary parentheses. Okay. Now distribute the minus. So it's going to be a minus 3 and a minus 2i. Distribute this minus. And what are we going to have? Negative is... Okay. And then is that a minus?
Minus
I? Okay. Now let's combine the like terms. What can I combine with this 2? It's a real number.
The other 2 and the negative.
So the 2, the negative 3, and the 2. 2 minus 3 is negative 1 plus 2. Is that going to be a 1? Now let me mark those out. And what about the imaginary numbers? We have a negative 6, a negative 2, and remember on this I, where there's not a number in front, you assume there's a 1. So just add negative 6, negative 2, and negative 1. What's that going to give us?
Negative 9i.
Negative 9i. Do not get an 8 somewhere out of that, okay? The 1 and the 9, don't do that. Back in the olden days when Pearson was all multiple choice, this was like many, many years ago, you know they had the negative 8i. They had the trickiest answers possible. People would get there and then they say, oh wait, negative 8i, maybe that's the right answer. So, don't do that. 1 minus 9i. Good. Any questions? Adding and subtracting complex numbers is just combining like terms. Combine the real numbers, the things without the i's, then combine the i's. No. Well, before we do that, when I want to review something, a little red rule that last time, that square root of a times the square root of a. Oh, sorry. Lower, yeah. The square root of a times the square root of a is a. A stands for anything. The square root of anything times the square root of anything equals anything. Now, isn't it true that something times itself, instead of writing it like this, I could have written it like this.
Move the paper down.
Oh, yeah. The square root of a squared. Doesn't that mean the same thing as the square root of a times itself?
Yes.
Something squared. So we could rewrite this red rule here like that. Okay? The square root of a squared equals a. And when you see it written like that, that leads you to decide, okay, a square root and a square cancel each other out. Okay? I'm going to, let's see, before we do number 8, okay, so we're going to remember, let me go ahead and write that down over here. The square root of a squared equals a. That's a rule we're going to use throughout the semester. A square root and a square cancel each other out.
Remember, an I is just a fancy way of saying the square root of negative 1.
Yeah, I was going to have them, okay. Just like on problem number 1, we simplified square root of, what was it, negative 49. What if that had been square root of negative 1? How would you have simplified that? Square root of negative 1 is I. Let's square both sides here, because I want to develop a rule. I put a square there and there. Then on the left, square and a square root, they cancel out. So we just have negative 1 equals I squared. Let me write that reversing it. I squared is negative 1. That's a rule you're going to use on the rest of the problems we do today. I squared is negative 1. Every time you see an I squared, you're going to stop and replace it with a negative 1. Okay?
You can have an I in your answer, but you cannot have powers of I in your answer. Any power of I to the fifth, well, you could say it's I squared times I. So you should never have powers of I in an answer, except for just I by itself, I to the first power.
And if you have an I bigger than a square, you've done something wrong. You should have, when you got to the square, you should have made it -1. Okay? So this rule we're going to use here. And I also want to recall something before we do number 8. This is from your earlier algebra classes. Do you remember something called FOIL? So suppose we had this, 3 plus 5x times 2 minus 7x. Do you remember how we would multiply those together?
3
Yep.
times the 2.
Okay, 3 times 2 first. Uh-huh.
And then 3 times the negative 7x.
Mm-hmm. That would be what? A negative?
21x.
Uh-huh. First outer.
Then 5x times the 2, and that will be 10x.
Mm-hmm.
Then 5x times the negative 7x will be negative 35x.
Negative 35x. Not just x.
Square.
X times x is x squared. Okay? So when we're multiplying binomials, that's what this is called, 2 terms. You FOIL it out, and then you combine like terms. Okay, you have the 6, the negative 21x plus 10x. What's that going to be? Negative 11x. And then the minus 35x squared. Why am I reviewing that? Well, that's how you're going to multiply complex numbers. On number 8, it's going to be just like what we just did here, except instead of the letter X, guess what letter we're going to have? I. And then when you get the I square, you'll have to replace it with the -1. Okay? So number 8, I'll take, let me do it. Okay. This is number 8. We have the complex number 9 plus 4i times 5 minus 8i and notice if those i's were just letters like x, it's clearly a FOIL problem. Binomial times binomial. The algebra of complex numbers, the algebra of i's, is amazingly similar to the algebra of x's. When we're adding and subtracting complex numbers, we're just combining like terms. Here we're FOILing out, we're multiplying 2 complex numbers. We're just going to have to FOIL with one extra step. Replace that square with a -1. And you'll see that in a moment. So first, let's see. 9 times 5. Okay, 45. I'll get us started. Outer. Y'all don't want to talk. Y'all just want. Okay, I agree. The 4 times. The 9 times -8 is a -72, and have an I there. Inner. Plus 20i. I agree. Last.
Minus 32i squared.
Okay. Positive 4 times a -8. That's a -32, so we have a minus 32. And the I times I, just like x times x became x squared, I times I becomes I squared. And as soon as you run in, don't let powers of I build or linger around. As soon as you pick up a power of I, simplify it using the fact that I squared is equal to -1. So look at here's my thought process here. I have a minus 32 times, what did I say I squared equals? -1. So we have a negative 32 times a -1. What's this last term here going to become?
Positive 32.
A positive 32. Any questions on our logic there?
And I squared changes the sign of the number in front of it. And that's all you got. Instead of a negative 32I squared, it's just a plus 32.
Any questions on our logic before we go on from there? We're not through with this.
But you've done the hard part.
We've done the hard part. Now it's a matter of combining like terms. What can I combine the 45 with? The 45 plus 32, the real numbers here and there. That's going to give me...
Is it 77?
Yes, it is. And then we can combine the i's. Negative 72i plus 20i gives me... I agree. For my final answer.
Now don't subtract 77 minus 52.
Does it matter what we put first in the thing?
It used to not, but now it seems like they've changed the program so that it does.
I think if we, let me try it. Negative 52i plus 77. I think it's going to say, oh, no, it took it.
They took 5.
There was some yesterday where it said, oh, you have the right answer. It's in an equivalent form, but write it in the form A plus BI. That's why I've just been so careful only writing it, with the I at the end. Because yesterday I was saying, oh, you can write it however you want. I did that on one of the problems, and it said wrong. Your answer is not in the correct form. So it depends on how it's programmed. Okay.
So I hate to say this, put the thing without the I first. That's my habit. I would have never, but Tony was a little looser on that. But for me, I always put the I last. The I term
I
last.
think we have like 4 or 5 of these.
Oh, this
Look
is a
at number
good
9.
one. Oh, I like this.
The most basic type of problem solving is if you know how to do one thing and you're confronted with a new problem, just rewrite that new one to look like the one you know how to do. What am I trying to say? Poorly. Well, we know how to multiply if there's 2 sets of parentheses. You FOIL it out. What am I trying to say poorly that we should do on this?
Write it twice. That 2, that exponent, means you just have negative 7 plus 9i times itself. Negative 7 plus 9i. So we could write it. If we write it twice, then I think we're going to know what to do. It's a parenthesis, a complex number in parentheses times another complex number in parentheses. Now that
wait. Has he written it so it looks like number 8 now? Yeah. So
let's FOIL it out.
Basic problem solving. If you know how to do one thing and you create something new, make it look like what you know how to do.
First, negative 7 times negative 7.
49.
Outer, negative 7 times positive 9i. Negative 63i. What about the inner? Positive 9i times a negative 7 is? Another negative 63i. Last, positive 9i times positive 9i. Be careful.
Positive 81i squared.
Okay, and let's take care of that I square immediately. Let's see, I'll use this. Positive 81 times a negative 1. This last term is becoming.
Is it a negative 81?
That's right.
You'll see why I wrote minus 81 up there. I squared is negative 1. So that red positive 81 times a negative 1 would be a negative 81. I squared just changes the sign of the number in front of it.
Just like this negative 32 I squared became a positive 32, the positive 81 I squared became a negative 81. So now we can combine like terms. Combine the things that don't have I. 49 minus 81. That's going to give me a negative 32.
32? Yeah.
Okay, negative 63i minus 63i.
Yep, you're right.
126i for my final answer. Any questions there?
Negative 32 minus 126i. Y'all following us? Any questions?
Seems like when I was in that little room over in the MC building that I taught in for 30 years, people had more questions. Now that we're spread out like this, y'all don't seem to have that many questions.
Oh, I don't think that has.
Negative times a negative, is that positive or is that still negative?
We don't have a negative times a negative.
Oh,
Oh, the negative here, negative times negative, that's positive. Negative times negative is positive, but look at this one. Negative 63i minus 63i. Though it's not multiplication, you're adding the negative 63 and the negative 63, that stays negative.
Negative plus a negative. That's basically what you're doing. Negative 63 plus a negative 63.
Gives us a negative 126i.
You're multiplying right here when you FOIL it out. Negative times negative, positive 49. Negative times positive, negative. Positive times negative. That's where you're getting the negative 63i. Positive times positive is a 81. I squared, but that I squared is negative 1. So positive 81 times a negative 1 is a negative 81.
I think there's another multiplication. Any questions there on number 9? Did you punch in the
I haven't
answer?
touched in the answer yet. Negative 32 minus 126i.
Mm-hmm.
So several more of these multiplying.
And now, this is not a FOIL problem. This is not a FOIL problem. Let me write it down and be thinking about this. If those i's were x's, before you learn to FOIL, you learn this other property.
That starts with a D, don't say divide.
What?
What's that D that I'm thinking of?
That's right.
Just distribute the negative 5i.
If the I were a letter like X, you distribute. That's what we're doing
The
here.
little marks.
Take the negative 5i times the negative 3. That gives me a 15i. Is that what you said? Now, let's do negative 5i times a positive 7i.
Negative 35i squared.
A negative 35i squared. And I'm going to immediately change that negative 35i squared to a positive 35. So that's becoming just a positive 35. And it's just, even though I think my lab would take 15i plus 35, I'm going to put the thing without the I first, 35. That's just my habit, plus the 15i. Any questions there? Yes, because it's just.
That's the standard form, and Pearson is trying to add the programming where I guess everything has to be like that.
I think probably some other teachers want that number to be first without the I. And so they're changing the programming so that it's. Yes, they want that I to be second. And I could go through why they might want it like that, but
for one thing, the way the instructions say type your answer in the form A plus BI, they might take it as 15I plus 35, but there's some other stuff yesterday, if you watched yesterday's video, where I was saying it'll take either answer and oh no it doesn't. Okay, so Even if they take 59 plus 35 today,
I had to call Pearson and ask him to change the programming just because I wanted you to write your answers the way I write mine.
okay, I'm sure they did.
Yeah, they know how to do that.
Yeah.
Hey, this one looks like very similar to what we've already done. I think this is another FOIL problem, isn't it?
Mm-hmm.
Okay.
Yeah, this is just another FOIL problem.
You have the complex number -7 plus 9i times the complex number 2 minus 6i. Okay. So,
FOIL it out.
first,
-14.
outer, -7 times a -6i gives me a,
Positive what?
that's
42?
right. Don't forget your I. Inner,
9i times 2 is that 18i? And finally,
let them say it. Positive 9i times -6i.
-64i squared.
I think it's 54.
right, it's a 6, not an 8. Unless I miscopied it, right?
But go back and make sure.
Okay.
Okay.
6, okay.
Okay, 9 times 6. Be careful. Have your calculator there. And what do you think I'm going to do next? I'm not going to tell you. You tell me.
-54i squared to a positive 54.
That's exactly what I'm going to do. Make it a positive 54. So we have -14 plus 54 gives me
-14 plus 54. I'm
Yes.
thinking that's a 40.
Yeah, it's a 40. 42i plus 18i gives me a 60i for my final answer of 40 plus 60i.
So what happens if it's like a -14i plus a 14i?
Then that's a 0. If it's a -14i plus 14i, I think that's about to happen in the next example. What's -14 plus 14?
That'll be 0.
So there's no I then.
Are you looking at number 11 or number 12?
Okay,
Oh, okay.
that's about
Oh, wait, I got to punch in that answer. What was it?
40 plus 60i.
Oh, notice. When I check this answer, look at and go on. Look, my grade's updating, but you might think, well, I only have to make a 70 to move on. Well, do more. Get 100. Look at number 12.
7 plus 5i.
It's 320 if you want a break or something, but we only have 3 problems after this one. Y'all want to keep going?
Break or keep going?
Keep going.
Oh, okay.
Yes. Realize if you need to take a break.
Anytime you can leave, go out, whatever.
Okay, you want to take over?
Oh, okay.
I'm ashamed to say I'm not used to holding pens and writing like that for a long time, and so my hands start cleansing.
Oh, Tim.
I know.
Please don't. Yeah, okay, you said you prefaced it by saying you're ashamed to say it. I'm ashamed to hear you say it. Okay, let's see. Another falling out, but look at this one. 7 times 7 is 49.
I think you go faster than me, Tony. I suspect they like you better.
No,
You're
if
going
I'm going
fast.
too fast, y'all tell me.
Outer.
I am going too fast? Oh. That is 7i times the -5i. Is that going to...
35i.
Uh-huh.
Inner. This is interesting. So positive 5 times positive 7, that's a positive 35i.
Then it's negative 25i squared.
I agree. Positive 5 times negative 5i is negative 25i squared.
Then change it to a constant.
Thinking of that I squared is negative 1. This minus 25i squared is going to be down here plus 25. Oh, wow, look at what's happening. I think that's what you were asking about a moment ago. Oh,
First time we don't have an I in the
yeah, there's not an I in the answer. We have a 49 plus 25, 74. But you'll see what's happening here with the I's. Negative 35I plus 35. No subtract out or cancel out, whatever you want to call it. You'll see where I just marked out the 35 I's. So I think this is the first problem today that doesn't have an I in the answer. Just a 74. Now, why did those I's subtract out like that? Y'all?
Because it is something new.
Okay.
It was a positive I and negative I.
Yeah, the way they're both is the same complex number, except one has a plus and one has a minus in it. Here's a definition.
In algebra, we call that a difference of two squares. That's what a difference of two squares. You have the same terms, except the middle signs are opposite. And when you pull out a difference of two squares, you lose the outer and inner terms because they subtract out.
Here's a new word, not new to the world of math, just new to you probably in the world of your world of math. Conjugates. A plus bi and a minus bi. If you have two complex numbers that differ only by the middle sign, one's a plus and one's a minus, they're called conjugates. And what's special about conjugates? If you multiply two complex numbers that have the same numbers except for the middle sign, if you multiply conjugates, you get what type of number as your answer? A real number, an imaginary number, or a complex number? What am I going to say? A real number. If you multiply conjugates, you get a real number. That's going to be important for the next last three problems we do. And let's see, we've added, we've subtracted, we've multiplied. What's the only thing left to do? Divide. Okay? So,
notice we're dividing, we're denoting the division with a fraction
fraction. So look at what number 13 is going to look like. Oh, right. Well, with it looking like that, let me write out how to divide complex numbers. This is the one thing that isn't like the add, subtract, multiply. There's a whole very similar to just plain algebra, right? You combine like terms, or you distribute the minus, or you FOIL. To divide, it's a little different. So I'm going to write one of my world famous sentences. Tim, do you want to change so they can see the...
Yeah, I'm going to. But there was something I wanted to mention. Remember the last time, those last problems, Tony said, we said that if the...
you don't want a square root in the bottom of a fraction.
What is an I representing? Isn't that a square root of -1? You don't want a square root in the bottom of a fraction. So that's why we're about to do what we're going to do.
To divide complex numbers, it's going to sound strange, but not hard. Multiply above and below by the conjugate of the denominator. Above and below, multiply above and below by the conjugate of the denominator. And remember what the conjugate is. That's just change the middle sign. And denominator is at the top of the bottom. Bottom, yeah, denominator down.
And why do we do that? Because we don't want a square root in a denominator. So the reason why we're getting rid of the I from the denominator, why we're having to multiply by the conjugate, it goes back to this notion, no square roots in the bottom.
So 7 plus 3i divided by 1 plus I. This is number 13. 7 plus 3i divided by 1 plus I. So, we're going to wind up foiling twice on here. Let's see. I'm going to put parentheses around here. Now, what is the conjugate of the denominator? 1 minus I. You change that middle term. Don't change any other sign. Just change that middle sign, I should have said. So 1 minus I. Multiply above and below by that. And you're going to have to FOIL twice. Why are we multiplying by the conjugate of the denominator, you might wonder? Well, remember what we said. If you multiply two conjugates, do you get an I? No, you get a real number. So when you're dividing complex numbers, what your answer should be is just, should not have an I in the bottom at the fraction. So, I made that statement I just made was really poorly worded, wasn't it? Okay, so let's FOIL out the top. Have a 7. And then a minus 7i. That's first outer. Plus 3i. Minus 3i squared. Okay, did y'all hear that? As soon as you get the I square, change it to yeah, so that's a negative 1 times negative 3. That's going to be a plus 3. Now let's FOIL out the bottom. You shouldn't get an I on the bottom here. We have a 1. Okay, first outer, is that a minus I? And then inner is a plus I.
Then it's a minus I squared.
Minus I squared. Where's my green pen? What am I going to change that minus I squared to?
2. Oh, positive 1.
Positive 1. We have negative. You change the I squared to negative 1. Negative 1. Are y'all following why I have a plus 1 right there in place of the minus I squared? And now let's combine everything. Let's do the top. We have a 7 and a plus 3. Is that going to be a 10? And then, let's see, negative 7i plus 3i. What am I going to write for that? Is that going to be a negative 4i? Do y'all agree? Any questions? And now, what's going to happen on the bottom?
It's for 2.
Okay, you're just going to wind up with a 2. Do y'all see how the i's subtract out? The negative I plus I. And 1 plus 1, it's just a 2 on the bottom. Now this goes back to problems 3, 4, 5. How do we simplify this? We don't leave it like that. You divide the 10 by 2. Is that going to be a 5? I'll put the little marks there to indicate I'm separating it. 10 over 2 is 5. Minus 2i. Where do you get the 2? 4 over 2? This is not something intuitive that would just be obvious. 7 plus 3i divided by 1 plus I is 5 minus 2i. Any questions?
If the number is equal to a number on the bottom, does that just equal out being a 1, or is that just I?
Oh wait, would be a
With like a different type of situation. So if it was a 2i over 2, would that be 1i?
yes.
It would just be I.
But Pearson will take it if you type in 1i. Okay? At least they used to always take it.
10 divided by 2, 4 divided by 2.
I think number 14 might be a better example. 5 minus 2i.
Any questions before we go on?
Oh, wait now. Number 14. Let me write that down. Or did you want to do it? 4. I'll do it. No, you can do the last one. 4 plus I divided by negative 5 minus 2i. Did I copy it down right? Yes, I did. Oh, I said I'd do it. Okay, so we're dividing complex numbers. That means we're going to have to multiply above and below by the conjugate of the denominator. Okay, with conjugates you change only the middle sign. So do y'all want to tell us what you're going to multiply above and below by?
Negative 5 plus 2i.
Yes, right.
Do not change the sign on the 5.
That's
only
a
that
common
middle
mistake.
sign.
Don't go sign changing crazy. You only change the sign that's in the middle.
You see, that's another reason with complex numbers. So you can say the middle sign. But if you didn't always write the I at the end, then you'd have to be saying, no, change the sign in front of the I term. So if you always write it in the form A plus BI, then it's just the middle sign you're changing.
Okay, here we go. Let's simplify the top. Y'all are going to tell me what it is, okay? First,
Or negative 20.
okay, outer. The faster we get through with this, the sooner you get to your Labor Day weekend. 4 times 2i, I agree with the 8i. Inner.
Negative 5i.
Okay, positive 1i times a negative 5. I agree with that negative 5i. Last, be careful.
It equals to 2i squared, but you have to change it to be a negative.
Okay, so the 1i times the 2i is a 2i squared. And we're going to change that immediately to, so we have a minus 2.
Any questions on that? That rule, replace I squared with negative 1. You do that every time you get an I squared term. That's why you don't need to worry about, well, what happens if I get an I cubed? You're not going to get an I cubed. Even if you had to multiply by another complex number, if you replace it with a, if you get rid of I squared every time you have it.
Okay, first, let's do the bottom. First,
25.
okay, outer,
Negative 10i.
inner,
Positive 10i.
okay, negative 2i times a negative 5. I agree with that. Positive 10i, look what's happening there. Last,
It's negative 4i, but changing it to be plus 4.
Okay, so negative 2 times positive 2, I agree, is a negative 4, and I times I is I squared. And I'm going to change that to be a plus 4.
Oh, wow. This looks sort of messy, doesn't it?
It seems like I think maybe because I write bigger.
Well,
It just my
mine
print
looks
is.
messy too, so...
Well,
Oh, still. Let's see. Combine the stuff on top. What do we have? A negative 20.
negative 22, I agree.
Negative-
Okay, so negative 20 minus 2 gave us the negative 22. 8i minus 5i, that gives us the plus 3i. And look down here at the bottom. What's about to happen to those I terms?
They're going to cancel each other out, so it would just be 29.
Okay, negative 10i plus 10i, I agree, canceled out. We have a 25 plus 4. I agree with the 29.
And we can't simplify it.
But we do still need to split it up. I don't
That's
believe...
one of the things. It used to be Pearson said, do you agree that there's nothing you can cancel? If you
22
separate
over
it out.
29, 3 over 29,
We
there's
used to-
nothing to cancel.
We used to be able to type in the answer like that, but it won't let us now. Or at
Well,
least
you
it
can
didn't
type
let us
it
on
in and
Monday.
it counts it wrong.
So,
Uh,
Try again to see.
yeah, let's see. I'm going to try typing it in. Fraction. What was it? Negative 22. What should take it today?
Plus 3.
Plus 3i.
That's just a
Oh,
regular.
wait. Plus 3i.
I sort of wish that it would,
Uh-huh.
because
Well,
it
but
seems
that's
like
how I used to type it in.
they're going backwards, getting...
No.
No, you've
Well,
got to
you see,
split it
although
up.
your answer is equal to it's not in the correct form. Read the instructions. And the instructions talk about A plus BI. So let me just erase all of that. And let's see, I'm going to put a fraction.
Here's something while he's typing in that answer. When it comes test time and quiz time, there'll be a review beforehand, okay, that you'll do, and make a note. However they want the answer in the problem on the review. Every problem that's on the test or quiz comes from those reviews, okay? So the numbers are different, okay, but it's the same type of problem. We're not going to have something on the test that wasn't on the review for the test.
And we don't have stuff on the review that isn't in the homework.
So, however they wanted it when you were doing the review and the homework, that's how you have to enter it for the test. So that's what you're going to have to do.
Let's see. Oh, wow. Here comes the last problem. And I guess it's got to be the hardest one, right? The last problem. And
No.
I always tell them the last problem's the hardest, and I try for it not to be. Okay? To end on a light note, but sometimes it might be, but not this time. Look at this one.
I don't think we're going to have to FOIL twice, are we?
6 divided by 4 minus 9i. Okay, so we have a real number divided by a complex number. So,
Okay. We're going to multiply above and below. When you see that I down there in the bottom, you know you need that conjugate. What's the conjugate of that denominator? I agree. 4 plus 9i.
wow. I had not noticed this big hole here in front with all these wires and stuff. Huh. Be careful walking over here.
Was that there the last time? Standing here, I don't see that floor.
I don't know where it was that I just saw.
Was it there?
Step
And we're just
by.
now noticing it?
Well, just don't trip in it. Oh, wow.
Oh.
Is there one of those over here?
He's trying to stall to keep
No,
us
there's
here
one.
together. Uh-huh. Okay. We know we're going to have to FOIL the bottom. What do we have to do on the top?
Just multiply it across.
Use that D word. What is it?
Dispense.
Distribute. Close enough, okay? So, there.
24.
Plus 50.
6 times 9i. I agree with the plus 54i.
If there's any color ink we're using,
This
you have
thing is
trouble
no
seeing,
good.
just
I'm
let
having
us
trouble
know.
seeing. Okay, now we're going to foil. Let's foil in the bottom. First, 16, I agree. Outer.
36i.
Okay. You didn't say a sign, so I'm going to assume that's plus. Inner.
36i.
There's a minus 36i.
Negative 9i times positive 4.
Minus 81i squared, which turns into positive 81.
Okay, so negative 9 times positive 9 is a negative 81, and I times I is I squared, and that turns into a positive 81. You know, I'm having trouble seeing that 24.
Oh, yes. Going over it always makes it clearer.
I'm shadowing
Actually,
it.
it looks better.
There.
Maybe blurry. Okay. 24 plus 54i on top.
What have we got on bottom?
97.
97. Well, first of all, the 36i minus 36i is gone. And then 16 plus 81, I agree with 97.
And because we can't simplify it, it turns into 24 over 97.
We have to separate. Separate. So we have 24 over 97. I've got to move that stuff. Plus.
54i over 97.
This is nice because I don't see any common factors.
Yeah, 24 over 97 doesn't simplify, does it?
Is 97 prime?
97, I think, is prime. I don't think anything divides into 97.
So they make us split it up, but there's nothing to cancel. Any questions there? Yes. No, go back over it. I think I'm misunderstanding. I didn't hear your question. Say it again.
4 plus 9i over 4 plus 9i. Could you reduce that to 1?
But if we do, then we just go back to this form here.
And the goal is to
Get rid of the I from the bottom. But you're bringing up a good point. That's why we have to do it above and below. Proving 4 plus 9i divided by 4 plus 9i. That's just 1. That's the basic thing that allows us to build these equivalent fractions.
Look right here, you're multiplying by 1, the same thing over itself. So if you cancel that out as 1, you're back where you started with. Okay? So, but that's what you're doing. You're multiplying the fraction by 1.
Something divided by itself is just 1. We're multiplying basically by 1. It's a messy 1, but it's a 1. But if you did that, if you cancel that as a 1, then you're going to be back at the same problem, and you're going to be stuck with that I in the denominator.
Oh, gosh.
Any other questions?
Let me see. I'll stop typing it. 24. 97.
Oh, but remember, you got to move over. Don't put that plus in the bottom.
I didn't. I moved over.
I'm just saying, reminding the student.
54i over 97. And now, when I say OK, that should change to 100.
Let's see.
And then a little bit will be imported into Canvas.
Not that your grade matters.
Yeah, not that. I mean, I'm just saying for them, for their purpose.
I mean, not that mine and his grades matter.
Their grade.
But y'all's grades matter, and they'll be imported into Canvas. Any other questions? Now, I used to tell students, if you have a break in class, go to the library and, use their computers. But now the library's all torn up. So where do you go if you have a break in class?
There's still like a computer room that we could go to.
But where is it?
It's in the building with the cafeteria.
Okay. So the Harvin Center. Okay. I know they have computers in the Math Learning Center, CB 117. So if you have a break and if you have your own laptop, then you can connect it to the Wi-Fi and work on your homework. But but otherwise,
you're just stalling. I mean, are there any questions? I think I'll go ahead and stop the recording unless you have a question that you want that you think needs to be recorded and answered.